Okay, I was looking at my last video and I found a better way to make this even more clear, this comparison. So that's the reason I'm deleting the other video and I'm going to do it this video to kind of make everything come together better. So I'm using the FOIL method again. So first terms, multiply first terms, e squared, plus outer terms, e times f is ef, plus inner terms, f times e, which I'm just going to write as e times f again. I can do that because this isn't linear algebra, and we're not talking about groups and all that, fields and groups and all that stuff. So, and then I have f times f is f squared. Okay, so now what's in parentheses here times what's in parentheses here will give you e plus f quantity squared equals e squared plus, you got two EFs, 2EF plus f squared, like that. Now, I'm going to write this as, I'm going to let x equal to e plus b over 2a, like that, quantity squared. Remember, if you used a and b regularly, I'm using different letters. If you use a and b, the rule is first term squared times double the first and last term added to that, plus the last term squared. I'm going to use that same rule here. So I get first term squared plus, I'll write it this way, 2x times b over 2a plus b squared over 2, sorry, that's going to be a 4, over 4a squared, like that, okay? And you have a comparison here. E squared is the same thing as x squared. 2e is 2x, and f here. So 2e is 2x, and f here is going to be b over 2a. E is going to be x, okay? And then the f squared, b over 2a squared, is going to be b squared over 4a squared. You can't get more clear than that. Okay, now I'm going to take the regular quadratic equation, homogeneous quadratic equation, and it's homogeneous because it's set equal to 0, and I'm going to divide through by a. And then I'm going to do my little trick to make it look like this. Okay, so I'm going to write x squared plus, I'm going to put the x in front, this b over 2a times 2. Okay, so I'm going to put this 2x b over 2a, like that. And I'm going to take this c over a to the other side by subtracting from both sides. So I'm going to get negative c over a, like that. All right, now I'm going to complete the square. So I get x squared plus, I can rewrite this, doesn't matter which variable's in front or not. So I'm going to change that to 2b over 2a for emphasis, which this b over 2a, as we did the comparison, is like this f in this equation. So I'm going to have plus, I'm going to add this squared to both sides, because whatever you add to one side you have to add to another side, right? Whatever you add to one side, you have to add to the other side, right? So I'm going to add that b squared over 2a squared, b over 2a quantity squared to both sides here. So I'm going to have b squared over 4a squared equals negative c over a plus b squared over 4a squared, right? Okay. Now I'm going to write this in condensed form, just like this x plus b over 2a quantity squared. So I'm going to write that in condensed form. So I'm going to have x plus this b over 2a, this quantity squared, equals negative c over a plus b squared over 4a squared. Now, if you multiply a number by 1, you have that number back again, right? You know, 1 times anything is just that number again, right? So if you had a million and you said a million times 1, it'd still be a million, right? Now, if I take this 4a squared and put 4a squared over 4a squared, and I multiply it by on this side right here, that's like multiplying this by 1, right? Okay? I'll show you what I'm saying. Yeah, 4a squared over 4a squared, right? Well, now you can cancel this a with this, so you just have 4a, right? So now you have 4ac. We had a minus sign. So now you're going to have 4ac over 4a squared. Okay? So I'll write it like that. X plus b over 2a quantity squared equals negative 4ac over 4a squared. Well, what's nice here? See this denominator and this denominator? They match, right? I still have the b squared over 4a squared. Now I can combine terms, b squared minus 4ac all over 4a squared, right? That's nice because now I can write this as x plus b over 2a quantity squared equals b squared minus 4ac divided by 4a squared. It looks like a 9, but it's an a. That's better. Okay, so now that I have that, I can pull out some new paper and rewrite this as x plus b over 2a quantity squared equals b squared minus 4ac all divided by 4a squared. Now if I take the square root of both sides, okay, I'm going to find out that x plus b over 2a equals plus or minus the square root, because remember you take the square root, it could be either plus or minus. Okay, square root of this b squared minus 4ac. What's nice about this denominator is the square root of 4 is 2, and the square root of a is just a squared. I mean, the square root of 4 is 2, and the square root of a squared is a. So the square root of 4 is 2, and the square root of a squared is just a. Now, that turns out nice because look, you got a b over 2a, and you got this over 2a, right? So now you're going to have x equals this negative. You subtract this from both sides to isolate x. This, see how this is positive b over 2a? Minus b over 2a will just be 0, so you have x by itself. So x equals negative b over 2a plus or minus. I would go through all the steps if I were teaching like a beginning algebra student. Trust me, I do. I'm very, very meticulous. B squared minus 4ac, okay, divided by 2a. Guess what? We have like denominators, so we can just combine everything. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This method, you would be surprised how much it's used in higher mathematics for finding the roots of equations in mathematics, chemistry, electronics, physics, all kinds of engineering. You're always going to be using this. So if you're a student of science or any kind of student, I recommend that you memorize this. So the roots of a quadratic equation equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, you'll have two roots there sometimes, and sometimes you'll only have one root, and sometimes you could have complex roots. Okay, if b squared is greater than or equal to 4ac, you will have what's called real roots. If b squared is less than 4ac, you will have complex roots. If b squared equals 4ac, then you will have only one root. Okay, those are the rules right there. All right, so with that in mind, I'm going to write the equation again with this in mind. Real roots, if b squared is greater than or equal to 4ac, real roots. If b squared is less than 4ac, you have complex roots. If b squared equals 4ac, you'll only have one root because this will go to 0, and you'll only have one root. Okay, so now I'm going to write that formula again. X equals negative b plus or minus the square root of b squared minus 4ac, all that divided by 2a. And then I'm going to take a problem, x squared plus 10x plus 25 equal to 0. And I'm going to plug it in, okay? You could write this as 1 times x squared. So you got x squared with a equal to 1 plus 10x, so b is going to be 10, plus c will be 25, okay? Because you're comparing it to ax squared plus bx plus c equal to 0. That's your quadratic equation format right there, okay? So here, a equals 1, b equals 10, c equals 25. So now you're going to have negative 10 plus or minus the square root of b squared, 10 squared, which is 100, minus 4 times a, which is 1, times c, which is 25. And we're going to divide that by 2 times a, which is 1, which I'll write it out like that. Dot means times. Okay. And then you're going to have x is going to equal to negative 10 plus or minus the square root of 0. You see why that's 0? Because 100 minus 4 times 1 times 25. 4 times 25 is 100. Okay? Divided by 2. So x in this case will only have one root, which will be 10 divided by 2 is 5, and you got a negative sign, so it's negative 5. Always test it. Let's plug it into the original equation. So we have x squared plus 10x plus 25 equal to 0. Let's see if it satisfies that. So negative 5 squared plus 10 times negative 5 plus 25 equals, we don't know yet. We got to solve it. Negative 5 squared is just negative 5 times negative 5, which is positive 25, plus 10 times negative 5 is negative 50, plus 25, positive 25 plus positive 25 is 50, plus negative 50 equals 0. So yes, it satisfies the condition that ax squared plus bx plus c equals 0. This equation, x squared plus 10x plus 25 equals 0. So the root to this equation is negative 5. Negative 5. And if you really wanted to write it like this, you could say, well, the root equals negative 5, right? Certainly you could say x plus 5 equals 0, right? And you could also square both sides. X plus 5 squared equals 0 squared. 0 to any powers is going to give what? 0. So you could say x plus 5 quantity squared equals 0. Okay? So if you plugged x equal to negative 5 in here, negative 5 plus positive 5 is 0. 0 squared is 0. So it satisfies the equation either way you look at it. So that is how the formula for the quadratic equation, ax squared plus bx plus c equals 0, is derived. X equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a.